What are these two things on the screen? Minions. Are they the same ones? How do you know? They look the same, so they are the same, is it?
Oh, they're not the same. One of them got a black and white.
What, black and white?
And the eye.
Okay, it's not meant to be there. These two black stuff is not meant to be there. So let me try and replicate it. Okay, now they are the same, right? Okay, I don't know what this is, like, it's not meant to be there. But since I cannot erase it, I'll just include it for the other one. Now, in mathematics, two figures are congruent if they have the same shape and same size. C-O-N-G-R-U-E-N-T. Congruent. Okay, how about this triangle and this triangle? Do they have the same shape? Do they have the same shape? What are their shapes? They're both triangles, right? Okay. But when we use the word shape in congruency, when we say same shape, we are referring to the angles being the same. Okay. So for example, these two triangles, they obviously are, they look quite different. Okay. So if I draw another triangle, same shape, it's going to look like this. So this angle and this angle are the same. These two are the same. Then these are the same. Now these two triangles, they have the same shape. I hope you understand what I mean with these dashes. So the yellow ones are the same. The ones with two dashes, they have the same angle. And the one in blue, the three strokes, they have the same angle. So these two have the same shape. I consider them having the same shape. Looking at these two triangles that are just true, do they have the same size? Do they look about the same size? About the same size? Yes, right? Okay, so size refers to the comparison of length. So in this case, this side and this side, same. This and this, also same. These two, also the same. So these two triangles, they have the same shape and the same size. When I say same shape, I'm referring to the same angles. Is it possible to have, let me write this down for us, same shape, same size? Is it possible to have same shape, different size? Possible? Let me copy down this triangle first. Oops. Copy. Paste. Okay. Now this triangle versus, see, it's the same one. I'll make it smaller. Okay. Now these two triangles on the right, do they have the same shape? When I say same shape, I'm referring to the angles. Are the angles still the same, right? Do they have the same size? No. So don't have. So it is possible for us to have triangles of same shape but different size. In this case, this will be called congruent triangles. This one over here would simply be called similar. S-I-M-I-L-A-R. Triangles. Okay, these are the two keywords we are going to learn for this chapter. Congruent and similar. In this case, these two minions over here, they are the same shape, they have the same size. So they are congruent. Okay? Now in our classroom, is there anything that is congruent? Give me a... So here we have two figures. Got A, B, C, D. Then I've got, what is this? Do you have A or P over here? What do you have? A prime. Okay, we call this A prime. Can you do me a favor? It's not meant to be A prime. It's meant to be P. P, Q, R, S. Please change it to P. Okay, then Next, in figure ABCD and PQRS, there shouldn't be this apostrophe. We have the corresponding angles. Now, I need to tell you that these two shapes, they are congruent first. Okay, these two are congruent. We see that there are certain sides that are the same. There are certain angles that are the same. So just put in a line over here first that ABCD is congruent to PQRS. This is given. Okay, so if the question tells you that ABCD is congruent to PQRS, then we can continue. So now, the next word that we need to be very familiar with is this, corresponding. How have we seen the word corresponding in maths before? Have you seen the word corresponding in maths before? When? Which kind of topic? When have we seen the word corresponding? Yeah, angles, right? We call this A and B. Angle A is equal to angle B, corresponding angles, parallel lines. I hope you remember this. Corresponding. So you see that angle A and B, they have the same value. It's the same angle. They have the same type of shape also. They are formed by this and this. Okay? So we call them corresponding. Now in this diagram, we're going to identify angles that are corresponding as well. Okay? So very clearly, I know that this 60 over here is the same 60 over here. So this is how I phrase it. Angle ABC, okay? Angle ABC corresponds to angle PQR. Easy? They are the same angle, they are corresponding angles. Just like in our parallel lines, we also have corresponding angles. Same for this. Do you think you can do the rest for yourself, by yourself? The rest in this table? Can you take just 30 seconds? First one, what is it going to be? First one? QPS, okay? Third one? QRS. And the last one? RSP. All of you have that? Are there any other variations of the answers? For example, can I say that this is actually SPQ? Cannot. Anybody has that? SPQ? Let's see where QPS is. QPS. QPS refers to this angle. SPQ, also the same angle. So I should be able to accept that. But in this topic, we have a systematic way of writing things. Just as we say, ABCD is congruent to PQRS. A with P, B with Q, C and R, D and S. There is an order that we are going. So my recommendation to you is you follow the same order. So if you have SPQ over here, just note that your value is the same, but naming can be improved. So I only want to see these answers. Okay? Check that you have exactly the same as what I have on the screen. I want them to be exactly the same. The order matters. It will help us in future. You know that it is possible to come up with all these answers without referring to the diagram? Anybody has an idea of how to come up with these answers without looking at the diagram? Think about it. We have dealt with the corresponding angles. we also need to consider corresponding sides. Since you can do corresponding angles, right? Corresponding sides is easier. Okay, let's start with the first one. AB. AB over here corresponds to, can I have an answer from the class? PQ. Should I say QP? No lah. Okay, so actually we also can do the same thing to fill everything up without looking at the diagram. Let's not look at the diagram. Let's try and fill everything up. BC corresponds to QP. Are you read what? QR. Okay, next. CD corresponds to RS. DA SP. Now we refer back to our diagram. We see whether do they make sense or not. And they should lah. Okay? Okay, property 1, corresponding angles are equal for congruent figures. Corresponding sides are also equal. So we have dealt with the corresponding sides and the corresponding angles already. Easy, easy. Page 3. Identify two pairs of congruent figures. So these are our answers. B and D, C and F. Let's take a look at B and D. Same shape, heart shape, same size, but rotated right. Even though it is rotated, does it still have the same shape? Even if you rotate a square, it's still a square, right? Yeah, okay, still same shape, still the same size. What about C and F? Obviously, circles is the same shape. Circle is just a shape. You can't have any variation. But size, you can tell that they are the same. Okay, so this is correct. Practice 2. Now, given triangle ABC is congruent to PQR. Are the names important? The names important? Yes, it is important. Complete the following statement. Now, without looking at the diagram, don't look at the diagram. Can you fill in the blanks? AB equal to? AB equals to PQ. What is equal to QR? BC. And BC is equal to what? QR again. Okay, let's refer back to our diagram. Does it make sense? AB over here and PQ. One stroke, right? One stroke. Then QR with BC. 3 strokes. And then it's the same again. What happens if I did not teach you that you are able to find the corresponding sides from the names? Let's pretend that we didn't learn that. And I want you to find the corresponding side for AB. You will be able to identify it is this one, right? But what will we call it? Will we call it PQ or QR? Now imagine I didn't teach you how to get the corresponding sides from the names. Then I ask you to find the corresponding side for AB. What are you going to write? Are you going to write PQ or QR? And how do you decide? You see the problem? It is still doable, right? My side A has 1 stroke over here and 2 strokes over here. All you need to do is to find the side that has 1 stroke and 2 strokes on either side. So I know it is supposed to be PQ. This is the answer instead of QR. But it's quite tedious lah. I mean, you have to think a bit more. So the trick is to get the answer from the name. It's easier. Alright? Next, let's do the corresponding angles. BAC. BAC must be the corresponding angle will be. What is it? Help me out. QPR. Okay. Now RQP, corresponding angle must be. Okay, good. And the last one. ACB. PRQ. Very good. Any difficulty with this? Or too easy? Yeah, what's happening? Huh? Oh. Right, example number 1. These two triangles are congruent. Find the length of BC. Part A. So what do we write? BC equals to how many cm? 4. Oh, they didn't say cm. Okay, 4 units. What about part B, part 1? Angle ZYX. ZYX. Okay, this one over here. What do you think it is? And how do we decide? So my working will look like this. Angle ZYX, I will write down the corresponding angle first. Instead of just writing 68 or 35 or whatever it is. Okay, so ZYX must be angle BCA. So I search for BCA. BCA, oh, this is 68 degrees. No need to guess. In our secondary school maths, no need to guess. So B part 2. Angle XZY. XZY. So A, B, C. A, B, C. Oh, what is this angle going to be? I don't know what's the angle. Can you help me out? Angle ABC. What is it? No, you tell me the working. 180 minus 35 degrees plus 68 degrees. Oh, then whenever we do this kind of working, we need to state the reason, right? What is the reason? Angle, sum, or triangle. Good. And what does your calculator tell you? 77 degrees. Okay, good. Simple enough. So what have we learned? Identifying corresponding sides, corresponding angles. Everything else was just a recap. Example 2. ABC congruent to X, Y, Z. Find the length of YZ. YZ over here. So I need the corresponding side for YZ. What is it? From the diagram I cannot tell. But I will be able to tell, but it takes a bit of difficulty. There's an easier way. What is the corresponding side to YZ? BC. Then I just search, where is BC? Ah, it is 8 cm. Much easier. Now angle XZY. XZY. So ACB. ACB. Okay, we're going to use the same strategy. Minus 80 degrees plus 60 degrees. So that gives us 40 degrees. Angle sum of triangle. Okay, example 3, you've got 1 minute to do it. Until 1.5 minutes, until 1:06. What is the length of KL? So KL is supposed to be equals to AB, which is 4 cm. And perimeter KL, MNOP. Okay, basically this perimeter. This we know is 4. So this must be over here 2. And we got everything else right. So perimeter equals to the same perimeter over here. So instead of copying so many times, I shall now write down the answer. 2 plus 2 plus 5.4 plus 6, 4 and 4. What is the answer? 23.4. Moving on. Okay, now in geometry, we've got this thing called transformation. Like your transformers, they transform, right? From car to robot to plane, they transform. In our geometry, it is not as cool, but they also transform. The ways that they transform, the first one will be reflection. So let's fill in the blank over here, reflection. Okay, here, point, this triangle KLM is reflected along the line AB. So this AB over here, you can treat it as a mirror. What do you think the shape is going to look like, the image? Can you try drawing? Do you have the same as mine? Exactly the same? Yeah, okay, this is correct. What if we have it this way? Hang on. How about this? Is this considered a mirror image? The one that is on my screen right now? Who says no, it is not? Resign. Who says I'm not sure? It looks like a mirror image. Okay, who thinks it is not a mirror? Who thinks it is a mirror image? Anybody? Okay, majority of you got it correct. This is not a mirror image because the distance from M, the shortest distance from M to the mirror must be the same as the shortest distance from the mirror to the corresponding point over here. So this is my reflection of M. Okay, which means that my diagram should be shifted here. Okay, so this one, this part, they have the same distance, same shortest distance. So I call this point M prime. M prime. So next one will be point K prime. So this portion we have 4 units. So this over here must also be 4 units. This part 4 units. This must also be 4 units. This point will obviously be called L prime. Prime, yeah, like Optimus Prime. Prime. So the instructions are given at the bottom. Point K and its image. This is known as an image. They are equidistant from the line of reflection AB. When I reflect this way, did the angles change? This angle, L prime, M prime, K prime. It has a corresponding angle, L, M, K. This part is a 90 degrees, 90 degrees. The angles didn't change, so it's the same shape. And quite clearly you can tell that they have the same size. So we say that triangle KLM is congruent to K prime, L prime, M prime. Just like my example of my shoe. Mirror image, but same shape, same size. Besides reflection, we have this thing called translation. Translation simply means moving it in a certain direction. Moving a point in a certain direction. Now, here I've got point L. Okay, so you can see clearly it's point L. This triangle is transformed from the original to the, this is known as the image. Okay, it is transformed from the original to the image. Now tell me, is this a reflection? Yes or no? No, it is not a reflection. Very clearly it's not a reflection. It is some other transformation. And let's see how did the point L change. Point L came to this point, L prime. How did it move there? It went from here okay, from the start to the end. Let's take a look at point K. Hui Song, you'll be coming up to show us how point M changes. So this is K and this is K prime. How did K go from its original position to K prime? This is a blue line. It went this way. Okay, do you see any similarities between the two blue arrows? Yes? Okay, Hui Song, your turn to come up and show us for point M. Every single point is translated 3 units to the right, 1 unit down. Can you see that? In the blue arrow, including what Hui Song drew for us. Every point, 3 units to the right, 1 unit down. So this is the transformation known as translation. From the original to the image. So I need to be able to describe this translation very precisely. And how do we call it? Just now, how do we describe it? 3 units to the right and 1 unit downwards. So we will say the translation vector AB is just a name. We write it this way. 3 units to the right and 1 unit downwards, right? Do you have a problem with this way of writing 3 and 1? This 3 and the 1. The 3 in this case represents 3 units. The 1 represents 1 unit. But how do I know whether it is to the left or to the right or up or down? I need a reference. My reference is my x and y axis. Getting a bit confusing, but no worries, it's not difficult. X, this 3 over here refers to the number of units along the x-axis. If it is positive, then we are going to the right, just like our x-axis. Okay? What happens if I have negative 3? What does this negative 3 now tell me? Moving to the left, how many units? 3. Moving to the right by 3 will simply be just 3 over here, right? Correct? So the negative sign tells me the direction according to my x-axis. What does this sound like to you in physics? What does this sound like to you in physics? I talk about magnitude, I talk about direction. Something that starts with V. No, not velocity. Vector. You learn scalars and vectors, right? Vectors have magnitude and have direction, right? So this 3 over here is the magnitude. Whether it is positive or negative tells me the direction. What about the 1 over here? It's going to be 1 unit either up or down. In this question, is it 1 unit up or down? Down. So should I leave it as 1 or should I leave it as negative 1? Negative 1. Because up is positive. Right is positive. Get it? Is this important to you? Actually, no, it's not going to be tested for you at your Sec 2, but it's tested in Sec 4. But since it is here, I just tell you a little bit more about it. Okay? Basically, every single point on the triangle including, for example, if you like, this point. Let's call this n. It is translated to this point, n prime. 3 units to the right, 1 unit downwards. So the resultant is like this. Okay, same. Maybe I should use blue color for this. 3 units right, 1 unit down. So that is just translation. Okay, now I'm going to show you what this means if without all the confusion. Since I'm using a laptop, I am now going to copy, and I'm going to paste it. Okay, suppose I put it over here. Can you name me the translation vector? This is the original. This is the image. What is the translation vector over here? How many units to the left or right? How many to the left or right? How many? 5? Okay, 5 units to the left or to the right? Right, so it is a positive 5. How many units up or down? 2 units, up or down? Up, so 5, 2 lah. Translation. Okay, what if I choose to put it somewhere else? Let me put it. Where got 5? Here lor. Okay, to this one. Okay, so 1, 2, 3, 4, 5, 1, 2. Okay, so I can put it anywhere else I like. If I put it, for example, here. Okay, what is this translation vector now? How much? What is the first number? 1, yes. Then 2. That's it. Enough already? Huh? Enough example already for translation? Alright, so please fill in the blank over here. We've got translation. Translation is simply moving it from one point to the other point. Reflection requires a mirror. Then we've got the last one. Rotation. I am sure you know what rotation is. You have to rotate about a point. In physics, they will say you have to rotate about a pivot. Right? Pivot. This is my pivot. Why? We are going to now rotate this triangle about the pivot. So under this rotation, center O, theta degrees anti-clockwise. This symbol is called theta. It's just another unknown. X, Y, A, B. Just call it theta. It is rotated anti-clockwise. So anti-clockwise is this way. Point K is rotated to its image, K prime, such that OK equals to OK prime. So here we have the rotation of 180 degrees anti-clockwise. By the way, 180 degrees anti-clockwise is equal to what? 180 degrees clockwise, right? Okay, they are the same thing. How about, for example, 90 degrees anti-clockwise? Equals to what? 270 degrees clockwise. Same thing, you must know how to change from one to the other. Okay, that's not the point of this question. So here we have a rotation. When you rotate this triangle, do you think the size changes? Do you think the angles change? Angles, do they change? No, the angles itself, they do not change also. So this will still be the same. This will still be my 90 degrees. And they're still the same. So they are still congruent. Okay, so let's fill in the last blank. This will be rotation. And under each transformation, an object is transformed to its image. It's just a name. So for all of these three transformations, a figure is congruent to its image under reflection. It is congruent to its image under translation. It is congruent again to its image under rotation. All these three transformations do not change shape, do not change size. Okay? If it is a yes, state the transformation that transform it. Right, so for the first one, congruent or not congruent? Okay, so yes. What is the transformation? It is a translation, yeah. Translation by how much? Yeah. Tell me the vector lah. Oh, yeah, how much? How much? How many? We go along the x first, x-axis. Is it moving to the right or to the left? Moving to the right or left? It is moving to the right, so it is a positive number. How many units? How do you get 4? Hey, oh, you all don't have the... So you cannot see the grid, is it? Okay, never mind. What is it that you measure with your ruler? 4 cm. Is that it? With your ruler? Measure this distance? 4 cm? Yes, okay, let's put 4 then. 4.1, okay, can I say 4.1? What about the vertically? Does it change vertically? No, doesn't, so 0. Okay? Let's try the second one. Part B, are they congruent? No, obviously not. Why are they not congruent? Yeah, they have different size. Next, C. What is this? Wait, congruent or not congruent? Congruent or not congruent? Congruent. Okay, what is this transformation? Rotation. How many degrees? About where? Rotation by how much? 180 degrees clockwise. Or you can say anti-clockwise, I'll still mark you correct. But about which point? Where are we rotating about? Where's the pivot? Anti-clockwise, clockwise, you're still going to say answer. Okay, so where's my pivot? Here. O. A, B, O, U, T, O. About O. Right in the center. Just try and draw right in the center. Just for information, we are not going to test you this part. You don't have to write it, but I'm just telling you so that you can visualize, okay? Rotation is good enough. And the last one, what is this? Are they congruent or not? Okay, yes. Congruent. What is the transformation? Reflection. Where is the line of reflection? The line of symmetry. In the middle, is this? Okay, just take your ruler and try and draw it. To get the precise answer, you can draw dotted lines like this to join them up. Then you find a midpoint, and you join. This will be your line of symmetry. Because that is how the reflection works? Okay, so X is supposed to be BE, which is the same as BC, which is 9.3 cm. Part B, Y. Y is equals to AC, which is DE, 8.5 cm. Part C, Z. Z is angle, BDE. So this must be equal to BDE, BAC, right? So BAC, 35 degrees. Oh, sorry, no. BAC, 180 minus 35 plus 64 degrees. Angle sum of triangle. How much is it? 81.